Hi guys, good afternoon. I'm back again with this another issue, which is add payment transfer charges. Okay, so in this particular issue, we are going to calculate the charges and then add to that payment whenever we are doing the payment transfer, just like the things we discussed previously as part of this diagram. Okay, we have the charges phase, so there we are going to calculate the charges, and this is this kinds of things. Okay, so for that we have this issue, and we are going to work on this. All right, I'm going to create a branch called 16 out of the main branch and then start working on this. So basically, this is the latest code that we have. Okay, so I'll just create another branch called 16 and start working on this. Pretty cool. All right, now let's say the code cleanup is a continuous process. Okay, so last time we write these things like this, and then if we want to clean up something, we have backed up by our use case. So that's the beauty of the use case. Let's say it helps us for the continuous refactoring of our code base with the confidence that have we haven't broke anything else. Okay. So for example, let's say if you see there are some duplicates here, all right. I'm doing the same statement again and again, again and again, again and again. So I think we can just replace this with something like this. If I just make this I don't know, so something like this, okay. Extract method, no. Maybe I would like to extract this as a method. So Alt enter extract method. So basically, still taking the payment. So I think what we can do is like private void. Okay, instead of taking the payment, we can take the account number. So saying that void validate account status, something like that, and I'll take the account number. Right, and then we'll take the status or something like that. So maybe I'll just take the account status, right? So in this way, we can simply do extract these methods to somewhere here and do the things instead of taking the instead of taking the payment, we'll just copy this one and do the things, and then here we'll just have the account number, right? So account number and then account number, then we are done. Basically, we're trying to the account number. Okay, so we're done. So basically now from here what we can do as part of the status, we can say that the validate account status, account number is payment that gets sender account number, status is account status that open. If we want to support multiple, we can do that as well. Validate the payment that get receiver account number and status is also open. So this way we just clean up few things. So we don't need this method now, right? Yeah, we don't need this. Again, we can do the same thing for this account exists as well. So instead of having this as a, let's say, I'll just copy this. Yeah, instead of saying the account receiver and this account exists, I will say that validate the account exists, and then I'll give the account number, the string account number, right? So I'll just remove this one and then the account number as well, and I'm done. And we also don't need this one. So basically what we'll do is like validate the account exists, right? So payment dot get sender account and now validate account exists, the payment dot get receiver account. So instead of if we want to refactor this, let's say refactor rename through if sorry what was the max transfer limit, right? So yeah, we can say that the validate, and instead of we are throwing. If we want that the validate is more confusing, then we have to say throws. Then you can add the throws as well. Okay, throws if the account not exists or something like that. So instead of open, we can take the status here. So it will just validate based on the status. Now, if you go back to the payment test case, we haven't changed anything related to my logic, right? We just refactor the course base. So we have to make sure that there is nothing is the payment use case is still working because we haven't changed anything to our business. We just refactor few things. So yeah, exactly the same. So this way, how the unit test also helps to refactor the things. Okay, as long as we have all of these our cases covers, then we can refactor that class or something like that pretty well. And it's a sorry, it's a incremental process. Okay. Now going back to the charges, what I did is like now we want to have one charges calculation as part of this payment process. So and I want to do this something like let's say something differently, okay? Because if we just go and check in some Java class and then do that calculation, it would be a similar thing, right? So we're already doing that kinds of things already. So what I would like to share here is like if we want to calculate the charges, all right, the first thing that comes in my mind is like the charges is something that breaks our system. Okay, can't that calculation could be externalized? Charges is something that is more custom, right? So charges is something that you want to add or you want to remove or is something that's really dynamic. When the payment process is there, charges is something that's really dynamic. That as let's say the bank or let's say the corporate who are facilitating this process want to customize that the particular thing. They want to have charges based on the user type, maybe they want to have charges based on the transfer amount, they want to have charges based on the date, maybe the Saturday and Sunday, and then the hours, maybe. Let's say if you are going to transfer in, let's say, the main hours, then the charges is high, or if you want to transfer in the less hours, let's say in the evening hours, night hours, then charges is low, something like that. So basically, charges is something that is totally has that needs to be as much as configurable as possible, as much as dynamic as possible. And if you don't have any charges in your system, even your system will work. So that means you don't have any dependency related to the charges in your system. For example, let's say what happens if I don't validate this validate account exists. This is not the validation, or let's say this validation can't go outside of my payment use case, right? I cannot externalize it. I cannot make the transfer from the account where the account number does not exist. So this is something my use case is really coupled with. I should make this couple because my payment use case relies on this. But let's say the charges or even the account status doesn't matter, right? If this account is exist but the account status is not open, or let's say some other status, that is something that banks wants to do. We don't care. If some banks wants to facilitate the payment from the any other status of that account, then that is also fine. So this validation also can be externalized, but not this validation also can be externalized. Okay, we don't care like if there is the maximum transfer limit or not, or let's say what is the maximum transfer limit. But this validation cannot be externalized. This is how we're preparing our payment transfer. So this is something how my system is operating. I cannot externalize this validation, but these tools can be externalized. So this is how we think about, let's say, having the validation externalized, or let's say any modules or any plugins or anything that we want to add in our system that can be externalized or that can be added or that can be removed. If there is there, I'm going to process data the way they have configured the things. If this is not there, if still my system will work. So that is the first question that we have to ask whenever we want to something really configurable, dynamic, or externalize. Okay, so and when we build the system, there are few things there comes a few things which cannot be externalized, or let's say which cannot be configurable. Okay, the account repository is exist. Account number is something that you cannot configure, or let's say you cannot make this dynamic, right? Because you eventually have to have this account number in your system to facilitate the payment. Otherwise, from where we are going to deduct the money, from where we are going to send the money. So this is the core of your business. So core of your business is something that your use case handles. And the add-ons to that business is something that is totally configurable. So this guy will provide that provision to add any add-ons, any configurations in that process flow. And then if that is there, then this guy will handle that thing and then take the results out of it and then do the things accordingly. Cool. So saying back this, okay, let's say we want to have one charges calculation in place so that if there is any payment processing, we want to have some charges. So in this case, we are just going to add some charges to that payment. So saying that, let's go into this model and then I'll just create one class called charge. Okay, charges, charge, something like that. So basically charge. So I'll just mark this as a data. We are providing the contracts, okay, the possible contracts that we understand about the charge. But how you prepare this charge, we don't care. So let's say this is some string, private string from account number, or let's say let's say from account number or debtor account number, something like that. Okay, whatever you want to call as charges. So okay, so maybe what we can do, a better name for this could be something like this. So let's say the pay account number, account ID or number. Pay is something who's going to pay, and then the payer. Okay, so since it's a charger, it's charges, so account number, right? And then the maybe you want to have the amount for now. That's it. Amount. We want to keep as minimal as that. So basically, if we have charges, and then maybe if you want, what we can say that the let's say descriptions or type or anything. Okay, so or yeah, something like that. So type, let's say the type or something like that. So basically, we wanted to facilitate one contract. What are the details about the charges that I understand, that my system understands? Okay. So this is the four attribute that we have added: the pay account number, the payer account number, amount, and type. Basically, we're done with the charges. Okay. So the charges model. And going back here, maybe what I will say is that, fine, let me just have one external service or something like that, which exactly provide me the implementation of this. So I'll just create the service. Here, what I can say that is like I'll get one class, which is the charge calculator. Okay. And then what you want to have is I'll give you the payment. For example, let's say I'll give you the payment. You have to give me the list of charges. That's it. So calculate or something like that. So I'll give you the payment. For now, we are giving the payment, whole payment, but what we can do if we want to clean up this more is like we'll just give the few information from the payment or something like that. Okay, for now, we're just exposing the whole payment object. Okay, now if I go back to my use case, when to call the charges? Okay, when to call the charges or charge calculator? This is something my use case is doing that. Okay, I don't want to calculate the charges once I receive the payment. I want to calculate the charges once the all the validations, let's say account validation and the status validations are done. So this is how the use case is doing. So once I do this, all right, and then what I would say is that please give me the charge. All right, so maybe from here, what I will say is the charge calculator that calculate for this payment. and say that okay, and if let's say if calculate is not empty, okay, then the charges, let's say the charges is not empty, then what we are going to do? Refactor, rename. Charges is not empty. Maybe I'll process the charges or whatever we want to do. So let's leave it now, okay? So basically we calculated the charges. This is what we wanted to do as part of this task. When the charges is ready, then what we have to do from these charges, we have the other tasks, refactor, rename, from where we'll be doing that things, okay? So basically is not empty, then I have to process the charges, something like that. So basically I calculated the charges. Now we need to provide the implementation of this. And if you see from here, okay, if you go back to the payment use case test, right, now we have one more dependency that we have in our added in our system. Let's say the mock private charge calculator, and then I'll provide the charge calculator here. Okay. Now, this there is apply, so maybe what we are going to, as of now, if you see the business as of now, this should be called to the calculate. This is what we want to verify, right? So, whenever there is the use case dot apply, then we should be calling the charge calculator dot, let's say, the calculate with this payment. So, this is what we want to make sure. This is it. And here as well. A payment more than this, then no, we are not going to call the, let's say, the uh, calculate in this time. So if, let's say, there wasn't call to this guy, so maybe verify, the verify, no interaction or something like that. Yeah, basically, we are not calling this guy or something like that. In this case as well, and in this case as well. So if you run this test case, our use case is done as per our current business process. We're just calling the task calculator and then we're getting the results out of it. We're not doing anything. So if you go back here, let me check what's problem. Yeah, the expected is safe, the actual is null. Why? Why is null? We altered anything here? Okay, no. I don't want it to do this. Okay, I just this is what how the test case. So basically, if there is a charge, then something like this. So don't want to touch anything in our previous process. All right, it will be in saved state, something like that. So something like this. Because if there is a charge, maybe we are going to process that charge. I don't know what we are going to do this as of now, but basically we calculate the charges and then charges is there as part of your use case. So if we run back this again, it will. Now, to write this implementation of this charge calculator, okay, one way of doing is like, let's just create the implementation of it somewhere here. I don't want to have this implementation of this guy inside my payment domain because this is something implementation of this is something that I don't care. Okay, so this is what we wanted to externalize. Let's say we want to create this as part of the external module, which is the payment and the charges or something like that. Okay, so I'll just have one payment charge module and then want to create the implementation. So and just like this, you can create another module called payment rule or let's say payment charges or whatever, and then you can have that implementation of this guy to that module as well. This is how we externalize the thing. Okay. So that way your payment domain is just expecting one implementation of the charge calculator whenever you use the payment use case. That's it. That's it. So new, maybe the implementation of this. So I'll say that which is the class IMPL implement charge calculator. Okay, fine. So if I just mark this as a service, then implementation is there. So normal way of doing, let's say, whenever the charges and these kinds of things is as a part of our business processing, what we do is like, okay, now we start writing the rules. Okay, payment, let's say get amount is less greater than 50, then I'll do this, or let's say I'll make this configurations from my system environment variable, and then I'll take the things from there or something like that. So eventually this charge calculation process becomes so much complex and so much noisy. We know that this is something that is our collection.empty list for now. Okay. So we know that this is something that can be totally customized, and then our payment use case does not even care about this. Is what is caring is like you have to provide me at least and this for information, PAE pair, and then the amount and type. Then I can process the charge. So we don't have to. You don't have to worry about any other thing. So to do that, okay, I want to give you one, let's say, eventually we strike in a point where we need some sort of rules or dynamic rules, or let's say a collection of rules, okay, that can be different based on the different implementation in the banks, or that can be different based on the, let's say, eventually they are dynamic. They are different based on the bank implementation. They are dynamic based on the their behaviors or something like that. So charges are so much dynamic and external component in this whole process flow. So in this case, maybe if I want to, I don't want to write all of these rules inside this charges calculator IMPL class. We can opt out to have some sort of library to do this. Okay, so there is a library called Drools. Basically, this is what I think we are looking for. If you see this example, okay, so these rules will grow so much, and then ultimately you want to have the amount, okay, so you will have a multiple combination, as I just mentioned, okay, how you are going to form the charges, up to you. How many rules? Up to you. What type of calculation? Up to you. So basically, we are providing the payment information and then calculate the charges for us. So this is if we don't have any charges, just return the empty list. Okay. So yeah, there is a tool called Rules, or any rules engine you like to have. So I would like to use the rules for this particular purpose, and then we can do things really quick, and it will have, let's say, it will have the rules that is really visual to us, and then much more cleaner to us. Okay, so let's get started on this. To do this, I'll be just adding the dependency of this rules inside our class path. Okay, so if you see the main repository, there is a key, it's KIECI. Okay, so if you check this tools documents, you will get the idea about this. So I'm basically going to implement uh, have this as part of my dependency, which is the bundle of all the things that we need, mostly about the, let's say, the rules. Okay, so and I added this. The second thing would be to have is like I need to have some rule file. If, as I just mentioned here, we need to have some sort of rules file. So I can write those rules into the DRLs or something like that. So if you go back here in the resources, what we can do is like, okay, what we can do is like we'll just have the rules files. Okay, so in the resources, new directory, let's say the charges, or let's say the rules for now, and then here is a charges.drl. Fine, fine. So if you have the DRL, then we can start writing any kinds of rules, no problem. So basically, it's a package. What's the package that we are using? So it's a package of rules. I think we are inside the rules, right? So we can simply keep that. And then what you want to import, maybe the payment. So what is the payment model? Let's import it. So since we need to have the payment to calculate the charges, so This is the payment. So payment, fine. Now, uh, fine. This is what we need, and then the let's say I want to have there are dialect. Okay, so even the dialect, I'm going to use MBL. I think there is a dialect called Java as well. Okay, so MBL is more readable dialect. So uh, I'm using this. You can use Java dialect as well. You can check out the Drools DRL dialects. Dialect is something that how your expression is looks like in the rule file. So what I'm saying is that rule. Let's say this is the one charges for all transfer or something like that. This is the example. Okay. So what rule is this? And then you want to have the when. I don't care what is the when, so I'm just saying 1 equals to 1 or something like that, okay? And then what you want to do is maybe you want to have, let's say I want to have one, uh, I'll just declare the global, okay, which is the list, or even the what I can say is like you need to have the list of charges, right? So yeah, what we can do is like you can declare the global. So if you to do this, okay, you have to go to the DRLs file and understand the syntax of it. So what I'm trying to do here is like whenever we collect this charges, we need to get back to the payment, or let's say the somewhere that is this guy is implementing it. So to do this, when 1 equals to 1, then let's say system.out.println. This is the charge I need. Okay, so one on an unexpected y when 1 equals to 1. Mm-hmm. Oh, maybe something like this. When no, when then. So we have the payment. Let's say the payment. Okay, and then the payment is let's say the object we have. Yeah, something like this. So um, I think this is the syntax. Okay. So whenever the payment 1 equals to 1, then this is just an example. Okay, we'll clean up this out. And then I need to call this as a charts calculator IMPL. So to do this, what I would be doing is like I need to have one. Uh, okay, basically something like this. You can create this exception, create class. No problem. Let me just simply add this class, extends the runtime exception for now. Okay. So we just and then let's say the errors. So what is the errors? Is runtime error. So invalid profile exceptions of uh, object for a while, and then the return new invalid. We'll update this. No problem. So public. Okay. So I think we're done. Public static as well. Okay. So we fix this, and then there is, let's say, we need to build the internal knowledge base, which is the Drools core, and then we want to add the DRL resource, and then these are the, let's say, the knowledge factory, knowledge packages, and then add packages. This is so whatever. Basically, we're trying to create one internal knowledge base out of this DRL file, which is basically this DRL file. So let's say, as part of the constructor of this, I want to do the same thing. Okay, so public this one as part of your constructor. I'll be initializing this. We can say that. Okay, So saying that, I'll just have not as a static for now, since we're calling from the constructor. And then what I would say is like, okay, please prepare one internal knowledge base for me. So internal knowledge base, which is internal knowledge base, which is the charges base, for example, private final. Okay, and then I'll just have this. So here, the charges base is what? Charges base is load. Okay, sorry, build or load. I need to provide the resource. So basically, to provide the resource, all right, what we can do is we know that there is a class path resource, right? So basically, this is from the class path. So new class path resource or something like that. So uh, resource factory, I think, yeah, internal IO resource factory. Yes. So this new class path resource, we have lots of utility methods to load the files from. So this is the class path resource, and then we are going to load is from rules, and then file name is charges the DRL. Okay, fine. So and then here what we need to do is like basically we'll be doing charges base and get the stateless session, I think, charges base that, and then new stateless, yeah, stateless KIC session, because we are going to use the stateless session. We have the individual DR files, and then we don't and there are the stateful session and stateless session, but in our current need we don't we can do that using the stateless sessions. Okay, so and then execute, I think, with the payment. All right. So what this guy is doing is like you are getting the internal knowledge base is already ready. So this DRL is compiled, and then this is everything is ready, just like your Java class. Okay, the rule is ready. And whenever you're trying to execute this payment request inside this session, then out of this internal knowledge base, you are going to create one stateless session, and then you execute this payment out of this. So let me just create the test case for this, okay, which is the calculate, I think. So basically, I need to have this test case, and if we want to, let's say the private charge calculator, which is the charge calculator, new charge calculator IMPL. Sorry, sorry. Yes, yeah, yeah, IMPL. And then as part of the calculate charges, what you are trying to do? Maybe the just the calculate, and the new payment. Okay, for now we are not doing anything. So let's simply new payment is not there. Builder fine. So payment dot builder something like that. Okay. So if you just run this test, you'll see the output from this DRL files, which is basically that this is something that I need or something like that. Okay, the payment Lombok package, the Lombok does not exist. Why? Maybe refresh this, and then let me one more time clean install. I don't know. It should be as a part of my pom.xml, so it should work. Let me just clean one time, and then I'll run it again. Okay, yeah, the payment config. So basically, in the payment config, we need to have one bin called the charge calculator. This is something that is needed in my payment use case, which is fine. So charge calculator, I provided the bin, and the things are there. So fine. Charge calculator IMPL. Let me just run the test case of it, and then we want to see the output first, okay, from the DRL file. Hmm. Package doesn't exist. Why? Lombok is there. Do you have anything related to the Lombok here? We have this, and as part of the main we have the Lombok, I think, somewhere here, right? So Lombok provided. Yeah, fine. So what's the problem? Mhm. Let me run one more time this, and we'll see that. Yeah, so it's running from here. If you see the precise out that we did here, maybe this is the thing I need. So basically, I'll just copy this and find it somewhere here. Yeah. So basically, if you see the charge calculator IMPL test, this guy is saying this is something that I need. So we are just trying to add charge for all transfer or all payment transfers. So there is no any check for now. All right, even we don't need this. So basically, we can just simply say that something like this. Okay, and then we want to do maybe, let's say, in the charge calculator IMPL, there are multiple ways to do it. Okay, one way could be you can initialize the things inside here, and then you can add the charges to that variable, and then get that variable out of the session. Okay, somewhere here. So you'll do this, and then you'll say that get globals or something like that. I think what this guy will give you. New stateless session dot execute. Maybe this is void. All right, fine. So payment. Yeah, set globals and so basically stateless session. I think you can have something like this. Let's say okay, and then they execute this, and then one way could be like get globals. Yeah, get globals and get something like this. So you can have the variable there declared, and then you can access that variable from here. The globals is one way to do that, and the other way could be something like this. So you don't have to have globals, okay? And then what you can do is instead of calculate, all right, or calculate charges, this and that, what we can do is like stateless the set globals, and this is the charges, let's say, all right, and then here you can see the new array list. So you pass the array list, right, of this type. So if you want, I don't know, okay, so you can pass the array list of type, or let's say the list of charges. This is the charges that I need, so I initialize this as a part of array list, and then I'll give these charges to you, and then I'll execute the payment out of it, and finally I'll return these charges. So basically, charges something like that. Okay. So saying that, what we can do is we have to have this variable there inside our DRL file. So okay, this is the global, fine, and this is the list of charge, which is the charges, right? So for the list, I think is a Java uh, list class Java that what is the util that list. So you want to import this as well, and then you also want to import maybe the com.eagle so dot payment the domain dot modal that the charges, right? So once you do this, and you this is the charge, fine. So you can say that, okay, fine, whenever this, then I'm going to add the charges that add, right? And then as part of the charge model, we can have the all ask constructor, okay? So that it becomes easy. Or even what you can do is like if you don't want to have, let's say, yeah, we can have the all ask constructor as well, and also we can expose the off method as well. So new CSARG chart. So what do we have here? We have the payer account ID. So let's say the payer is something, the sender of the payment. So what that's why we need this payment object, since we need to access the payment that has been uh, passed here. Payment dot get the sender account number, and let's say receiver account number is 00, for example. This is the system account, and then what you want is big decimal dot 0 10. So 10 is the charge, and then what you want to say, this is the system charges or something like that, or let's say network fee. Okay, this is an example. So whenever you are doing this, you are basically, why charges is this? No, this is fine, I think. Eventually we were adding, so given when then. So basically the thing is like the given when then and in rule is ended. Okay, and then we are adding the charges. So basically, no, we have the charges is the list of charge. So yeah, fine. So whenever there is, let's say this is the system account. So currently I'm just using 0000 something like that. Okay. So we can update this. So charges for all payment transfer, the payment one is 1 equals to 1 or something like that. So, for every conditions, and this is the fee. So this is how we just externalize the rules. So if you want to add some others, let's say payment if the amount is greater than 100, then you're going to have from the center accounts or from the receiver, from the center account to the system account is just one. Okay, saying that this is the, let's say, I don't know, this is a system fee or let's say something like that. So this is how we play with the fee. Since this component is totally externalized, we don't have to worry about the charges calculation. All right, and then the yeah. So if you go back to the IMPL and see the things, if you just run the test case that IMPL, let's run this. Let's build on payment with a valid payment. Payment. Sometimes my IntelliJ gives this problem. Okay, why the Lombok is not provided because of the provided. So this guy is not enabling the Lombok. What is the problem? Let me just remove this provided for now, and let's see what's the difference. Okay. All right. So charges calculator IMPL charge calculator. So basically IMPL test and then payment. Payment the builder. Uh, dot let's say the sender account number is 2, the receiver account number is 3, and the amount is, this is the valid payment that we need to have. And we, as whenever the payment enters in our system, we make sure that the we have the valid payment information, right, from the contract itself, so we don't have to worry about this time and again. Bill. So let's say this guy wants to transfer 10 rupees from this account to this account, and then we want to calculate the charges for this payment. Okay, so basically we know that if there is, this is the thing, then okay, so introduce, this is the charges. So charges is I think for this 10 rupee the charges certain that charge that size is equals to 1, I think, right? Okay, So this is how we make the things externalize, and then the now, for example, let's say what as part of this implementation, okay, we are providing one information about the payment. So basically now we are providing the payment, all the information about the payment, but we can provide the as minimal information that we want to provide. Okay, so this is how the contract are built, and then we are expecting the list of charges out of it. So implementation of this calculation service IMPL is external to our payment domain and implemented somewhere, maybe in other modules. Let's say you can have the implementation of this charge calculator inside the some other jars, which is you want to give to your bank. Okay, please write any implementation that we want to have for this charge calculator, and then give the implementation back to me, and so that the system will work based on that. So this is the one way of externalizing it. Or again, let's say even you write the charges things, you can just expose these rules to the users or something like that, and then they can just play with this, and then write the charges, and then you can read that DRL files from any source, even the GitHub, GitLab, or any repository or something like that. It doesn't have to have inside your class path. Okay, currently we are reading from the class path, but you can externalize this as well. So there are multiple ways to do it. How you want to customize or how you want to externalize your rules is depends on you and your need. But this is how we can externalize the rules like this, and then provide the flexibility of having this so flexible. And you don't have any rules coupled to your system, but you have, let's say, how I'm going to process that charges. Yes, is my business, but what are the charges is your business, or that is totally that can be externalized. Okay, so this is one way of doing it. You can think about another way of doing it as well. So this is the one way of doing it, using the rules, having the DRL files, and then having the. Okay, this is crazy. I don't know. Maybe I have some issues. I need to uh, uh, invalidate caches in my IntelliJ. Basically, this guy is giving me trouble. So I'll just run. No, controls. Okay. I mean, I can simply revert back the changes that I made about this provided, and then I'll just run this from the terminal for now. Okay. And then uh, I need to refresh, I think, my Maven or IntelliJ cache. Sometimes the IntelliJ gives this kinds of trouble. I don't know why, but whenever you invalidate the cache, then it will work again. So basically, it's not finding the Lombok in my class path, or maybe while running the so file settings. I think somewhere in the settings there is Lombok, right? So I think Lombok is enabled by default. So okay, let's see the errors. What is the error now? Errors 2. So basically payment, okay, charge calculation service IMPL. So this guy is saying that invalid rule file exception. No. Okay, let's check because we have added the entry. So in that case, what's the problem? We have one global of as a charges, right? So mhm. So we have the global list as charges, and then we want to add that charges to the this. So what's the problem? Constructor exception. Okay, invalid rule file. Yeah, fine. It is initially invalid. So why this is invalid? IMPL, this. Invalid rule file exception. Fine. So we don't have. Okay, maybe basically we just what we can do is like let's do one thing from where we're calling this. Yeah. Okay, does that get error? So let's print this error for now. So basically, what we can do is like, what is this? So we can just knowledge base build errors. We can take that errors here. Okay, and then errors. So let me just print that error for now. I will see the things. What was the problem? Or we can add the logger as well. No problem. So since we don't have any log here, we'll not get any idea. But what's the problem was is yeah, invalid null. Okay, let's run it again. All right, it will give the idea. Basically, we have the checks amount. Maybe this could be one issue, but I think it supports like in the MBL you can compare the, or maybe this is number and this is the big decimal, so that could be one issue, but I'm not sure. Hmm, fine. Okay, invalid root file exception is still null. Okay, so I printed somewhere. Mm-hmm. Mm-hmm. Let's have the constructor. Okay, then I will debug the thing. We had one base exception. I think it was the payment exception or payment exception. What was the data not found? Anyway, what is the controller advice that we added? And the advisor will, so I think we have base exception. So we have the base exception. I think we can extend the base exception and then provide the message to the super so that if there is an issue, it will be cached as well. Um, yeah, let's run it one more time and see the things. The problem is I'm not able to run this charts calculator IMPL alone, so it's taking some time. Okay, yeah, let's see. It should give you the error of let's say whenever it's trying to compile the DRL files, it's getting some error because of maybe we have missed some syntax. I think it was pretty straightforward. So let me just go back and then yeah, duplicate. Oh, okay, fine. You see the duplicate rule name and charges for payment transfer. So let's say charges for payment charges. So this is the network fee. Let's say network charge. This is let's say the system charge, something like that. So for now, we cannot have the same rule name. So that was basically the problem. System charges. You see the error from here. Cool. So let me run this one more time. Meanwhile, we can go up to our README file. Okay, what is the README? README, yeah. And we can add one more tools to our list, which is exactly the Drools, right? So we talked about the Drools and we write the very simple implementation for it. So basically it's a DRL file. You know, this is the beauty of the MBEL. I can just compare the, let's say, big decimal with this with the greater sign, something like that. Okay, so this guy will resolve that things for you. I don't think you are able to do that directly with the Java, right? You cannot compare, let's say, the big decimal the 10 is greater than 100. Can you do that? No. No, you can do it, right? Because this is not supported. This is, let's say, the number, and then this is the big decimal. But if you do the embed in the DRL files, you can do this as well. So let's say if we have another test case where the payment amount is more than 100, it should have the two when given payment large amount when calculate should have system charge, right? So yeah, so let's say instead of big decimal value of I'll give the something like 10,000, then you will use it to have two different charges, something like that. And in the this we can verify other things as well. So this guy is verifying the DRL files, and then the actually the implementation of charges calculation IMPL. So this is again, since your implementation of charges IMPL is external, all the test cases is also external. So oh, the component who is providing the implementation should make sure that you are calculating the charges pretty well. And now going back to our use case, payment use case. Okay, here whenever we try to process the charge or something like that, okay, and then at that part of time, maybe we'll check the accounts they are involved from the charges are valid, amount is valid, or something like that. So from there, we get the charges and then we verify those and then we process the charges, right? Cool. So I think, yeah, this is it for today, guys. We introduced about the Drools, a very simple DRL files as well, and then how to externalize the charge calculation part, and then how we think that this part could be externalized based on the needs, based on the behaviors, based on the nature of that components. Again, saying that we cannot externalize the checks, something like this, because this is my building block of my payment use case. I cannot allow transferring the payment, okay, from the account which not exists in my system. That means I'm externalizing whole the payment use case. So that means please build a business for me and then give that use case. I'll invoke for you. So this is not the flexibility we want in our system. We want the flexibility for the different components can be externalized based on its nature, but the core business is something that we're trying to build. So if you go back to this diagram again and see the things, all right. So from here, now you'd be able to figure out, let's say, which things can be externalized and then which things cannot be externalized, something like that. Okay. Okay, even the journal browser entries and this and that, this can be externalized. How you want to make the journal browser entry is something you can do, but eventually I need from where I have to debit and from where I have to credit or something like that. So yeah, okay guys, this is what we wanted to discuss today. All right, so I think, oh yeah, this guy is saying that inline the open. Eventually, we're just passing the open, so that's why. Okay, for now we can do this. IntelliJ suggests, let's say, yeah, empty statement. So we are not doing anything now, and we don't even, let's say, doing anything. So we can just leave it in. And other than this, yeah, we have some unused imports. Pretty clean. Yeah. Now this class looks pretty clean, right? So okay. All right, this is what we wanted to do as part of this task. All right, and then I'm going to post this changes in the branch 16, I think. So resolve the charges calculation. Okay, so I'm going to post this, and and this is it. Thank you guys. Thank you for watching. I'll see you in next video. Bye bye.